This video will help you prepare for our upcoming Chapter 3 test. I'm going to go through with you many of the skills that you'll be called upon to demonstrate. And please also know that I do put one or two questions on each test that ask you to go beyond the examples that I've shown you in class or here on this video. One skill you'll definitely have to demonstrate is looking at a graph, and just by looking you need to be able to write the equation of the line in slope-intercept form. So here's how I would go about doing that here. I know that slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. So it's a matter of determining the slope, which is clearly positive, because it's going uphill from left to right, and if you count it out, it's up 2 over 1, 2, 3. So the slope is 2/3, and I'm going to go ahead and leave that as a fraction. And then b is the y-intercept. That means where it crosses the y-axis. And here's the y-intercept. It's at a height of positive 3, so plus 3. You also need to understand the difference between a sequence and a linear function, and you need to be able to use both of those to model real-world situations. If you'd like an example of the sort of word problem that you'll be called upon to do, you can see your textbook number 8 on page 128. As far as the difference between the two things here, a sequence is only defined for whole numbers. So there's a u sub 0, u sub 1, u sub 2, but there's nothing in between. It's a bunch of dots, but you don't really want to connect them with a line. On the other hand, a linear function, y equals mx plus b, is defined for all values of x. X doesn't have to be a whole number. The function is defined even when x is a fraction or a decimal. You should be able to decide which is the more appropriate model for different situations. In other words, if I give you a situation, you should be able to say that should be modeled by a sequence, or that should be modeled by a linear function. You need to understand the concept of a line of fit, and you need to be able to understand what makes a line a good fit. You need to be able to do that visually, just by looking at the points and the line. That's explained pretty clearly in your book. And you also need to be able to evaluate how good of a fit a line is by looking at the residuals and computing the root mean square error. You should also be able to explain what the root mean square error means. So once you find it, you need to be able to describe what it means. You need to be able to find the equation of the line if you're given 2 points on the line, and you need to be able to first write that equation in point-slope form. So I'll just remind you how that's done. We definitely need the slope, so I'm going to go ahead and find the slope by plugging into the slope formula, which has me subtract the y values in the numerator and then the x values in the denominator. So that's 8 minus 4, and I need to make sure to go in the same order, so 5 minus negative 3. And then doing the arithmetic, 8 minus 4 is 4, 5 minus negative 3 is 8, and that simplifies to 1/2, or 0.5. So to write it in point-slope form, I choose either point, y minus, I'll just pick the first one, I'll use its y-coordinate, 4, equals m, in this case 1/2, x minus x1, x minus negative 3, which I'll write x plus 3. You also need to be able to convert that equation into slope-intercept form, and we're going to do that by just performing a couple of algebra steps. I'll go ahead and distribute the 1/2. I get 1/2 x plus 3/2, and then I will add 4 to both sides. And since I need to add the 4 to the 3/2, I'm going to write the 4 as 8/2. You could also use decimals here if you prefer. So 1/2 x plus 11/2. Again, I rewrote 4 as, well, it's 4/1 or 8/2 because that makes it easier to add to the 3/2. You need to be able to solve a system of linear equations using substitution as well as elimination, and you should be able to recognize which method would be faster, because on the test there will be two systems and you'll have to use substitution on one of them and elimination on the other, and you will save a lot of time if you know which method is faster just by looking at the system. Again, this is an overview of what you should study and what you should expect to see on the test, but also know that there will be some questions that are slightly different than what we've gone over in class and what I've shown you here.